Hello everyone, my name is Aditya Kumar and I'm going to talk about today on correlation and regression. These are the two very important statistics which we have in order to analyze the data points and further machine learning models as well. uh, we need to understand like what is correlation and regression. Generally, a data scientist or sometimes friends also feel a very quite similarity between these two statistics. But yes, there are some similarities as well as certain differences we have. So in this video, I'm going to talk about the differences between these two statistics and their interpretation, as well as I'm going to show you like how we can interpret and show the results as well, right? So what happens in correlation is generally the direction, like the magnet, the kind of correlation or the kind of relationship that exists between any two variables. It also tells you the directionality. It also tells you the strength of relationship between two variables. Like for example, we have two variables, age or income, right? For example, so if we understand by some of the common sense, then as you proceed with age, your income levels also gradually increases, right? So there is a strong as well as positive relationship between these two variables. Obviously we need to check with certain plots and all, because it's not holds true always and if for every data points. But yes, we always see the directionality between these two variables. So this is just for an example, but the as a concepts, whenever we need to analyze the relationship between any two variables, right? One of the way of generalizing and of course analyzing the two continuous variable is through the correlation analysis. It tells you about the kind of magnitude of relationship exist between the two variables, also how the direction is, whether it is in a positive correlation, whether it is in a negative correlation, right? For example, demand and price. As your demand increases, your price also increases. There is an upward relationship between these two variables, right? And similarly, supply and price. As your supply goes up, your price goes down. This is a very well known concept, right? So this is a there is a negative correlation exist. So we can also see like how we can plot, how we can visualize the relationship between or the correlation between to any specific correlation. But this is one interpretation of correlation. Now, from regression side, so there is a very slight difference between the correlation and regression. In correlation, you get to understand the direction of relationship. You get to understand the magnitude of correlation, like the relationship between two variables. However, in regression, you also to understand how one variable affects the second variable, right, or the other variable. So this is the extended, the kind of interpretation or the analysis that you can get it with the help of regression analysis. Okay, so this is a very quite one thin line difference between a correlation and regression. Apart from getting the relationship or directionality, you can also get to see the kind of how one variable affects the another in the regression analysis, right? And it helps you in terms of predicting your target variables in machine learning projects as well. Now I would like to show you how we can have the correlation statistics as well as regression statistics in Python with the simple use of few libraries such as Pearson R function within the SciPy library, as well as stats model library. We can have these two statistics calculated. And as I said earlier, like correlation will give you the directionality of effect as well as magnitude. However, regression is going to give you the how one variable is going to affect the another variable. So let's go ahead and see how we can calculate it. So I have activated like SciPy library here, and one of the data set which I am using right here, again same data set which I have shown you earlier. I am very much interested to see the correlation between the two variables, which is like customer lifetime value and total claim amount. We need to be very mindful that whenever we need to analyze the correlation between two variables, those two variables should be continuous in nature. The correlation should always be between the continuous variable only, right? So this is something that we need to be very much careful about it. So all these two variables like customer lifetime value and total claim amount, these are continuous variable, and we are going to have the correlation statistics. Once we execute these statements, we can have the correlation of 0.226. However, the magnitude seems to be very low, but again, since there is a positive value, so you can see there is a positive relationship between these two variables. One, when one goes up, the second one is also going up with the magnitude of 0.22 strength of relationship, right? So this is something that you can get it with the correlation statistics. And obviously right now I'm calculating Pearson correlation. However, there are certain other methods, like for example Spearman correlation, also tau also correlation statistics. But here I'm just showing you the example of Pearson correlation. In future videos I'll also talk about what type of different correlation statistics we have. Now, the visualization perspective, we can have the scatter plot between these two variables and see and try to see how the coordinates of these two variables tries to behave, right? So you can see there is a positive correlation in the starting of these numbers, but yeah, there's not a very strong correlation that you can see, since the data seems to be very scattered one, right? So while looking at this scatter plot, we can see like, yes, there seems to be a correlation but not a very high magnitude. Okay, so when we say high magnitude or high strength of correlation, I think it all depends on project to project and all, but in general, whenever any correlation statistic seems to be more than 60% or something, I think we should be considering those correlation as a strong correlation. Okay, now talking about the regression, which gives us the how one variable is going to affect the another. With the help of stats model library, I'm going to calculate and have that number with you. So I have one variable like in customer lifetime value, and y, which is as a dependent target variable, I'm considering as a total claim amount. So while specifying the regression calculation, since I have told you like regression is going to be very helpful in terms of predicting your target variable also. So in stat model library, I think you need to specify the target variable also, and that's why I'm giving you the x and y here. Now with the help of this one line statement, where I'm specifying like sm, which is the library function, and ols, which is the way we can calculate the linear regression model, which is the acronym of ordinary least square method. And then we can run the summary statement, and then we can get the results, right? So here the major thing that you can see here is like 0.0353, which is the coefficient between the customer lifetime value, which is independent variable, versus your target variable as a total claim amount. So this is the kind of you can say with the magnitude of one variable, how it is affecting to the target variable, which is your total claim amount. I'm not going very deep dive with linear regression and other interpretation of these statistics, because I'm going to have a separate videos on interpretation of these statistics as well. So I'm winding up this video on having the explanation of correlation regression here. If you would like to share your findings, request your more topics on, you can just ping me on, or you can just share it on your comment. And for encouragement, I think you can like and subscribe and share with others as well. Thank you so much for your time.